Hello everyone, welcome to SS Educare Teaching Learning channel. Thank you for all my subscribers. Those who still didn't subscribe, please subscribe and watch my videos. Your support is my strength. Let's go to our channel. Scientist of the Day. This American scientist was the first to get 1093 patents for his life-turning gadgets. This American scientist has developed a first research laboratory for himself. This American scientist had many hearing problems in his childhood. This American scientist, when he was at his young age, came from school with a folded paper in his hand. He handed over to his mother, telling that his teacher has asked him to give it only to her. His mother saw that paper and blushed with tears. She read it aloud that your son is very genius. This school is too small for him and we don't have such type of teachers to educate your son. So please teach him yourself, was the content in that paper. Then his mother has decided to keep him at home and teach by herself. She had a homeschooling for her son. Later, after many years, his mother died. After her death, this young scientist saw a folded paper in his old bureau. The paper he saw that paper which once he got it from school, which had the content that your son is adult. We would no more consider him as a student of this school. Please take him out of the school, was the content in that paper. Then this young scientist said, yes, I am adult, but I became the world's greatest scientist by my hero mother. Yes, that's the magic of the words. See, just a small word of encouragement has brought him to such a level of great scientist among all. He is called as the genius. That's the magic of words. He once said, a small word of encouragement and a love would change anybody's destiny. Thus, the scientist for the day is Thomas Alva Edison. He was the one who discovered incandescent light bulb. He was the one who discovered telegraph. Scientist for the day is Thomas Alva Edison. Welcome back. In my today's video, I will be teaching the remaining part of ICSE Class 10 Physics Chapter 1 Force. Let's begin with today's video. It's equilibrium of all the bodies. What is equilibrium? When does a body attains that equilibrium state? Let me see with an example. See, assume there's a body placed on a horizontal floor and one side the force has been applied. The force applied on this body, let's assume it is 10 Newton. Okay, how does the body, assume the body is here, the box or something, an object is here. I am applying force of 10 Newton on this body from this direction. The object will tend to move in the direction of force. That is first case. In the second case, as I am applying force from this side, I am also applying another force from other side simultaneously on the same object. What will happen to the object? Since the force applied or from this direction and another force is applied from the other side of the direction, both forces are balanced by the body. Thus, the object in between will not move. That is what is happening in the first example. In the second example, see, the force number 1 is being applied on the body from this direction, assume, and the force number 2 is applied on the body from the opposite direction. So that is force 1, force 2. One more force is applied on the same object vertically downwards, that is from up to down. And then fourth force is being applied on the same object from downwards. See, 4 forces, number of forces here are 4. Number 1 from this side, number 2 from this side, number 3 from down, and number 4 from down. So several forces acting on the same object from all the direction. What will happen to the object? The object will remain in that state only. So that state of body not moving when several forces are acting on it is said to be in equilibrium. This equilibrium of motion is similar to Newton's first law of motion. What is Newton's first law? A body tends to be in the state of rest or in the state of motion unless an external force is applied on it. Isn't it? If a body is in a state of rest, the body doesn't move unless and until an external force is applied on it. If a body is in continuous motion, the body remains in motion unless and until an external force is applied on it. What will happen? The moving body will stop if external force is being applied on it. That is what is Newton's first law. Is this law similar to equilibrium of motion or equilibrium of bodies? Yes, it is. So, what is happening? When so many forces acting on the same object, the net force acted on that object will become 0. See, assume force number 1 is 10 Newton and force number 2 from other side is 10 Newton, force number 3 from upwards is 10 Newton and force number 4 from downwards is 10 Newton equally. So what will happen? Net force is equal to F1 plus F2 plus F3 plus F4. And here F1 is 10. And here F2 is, since it is coming from the opposite direction, we are denoting it with negative sign. So minus 10. Then F3 is vertically, it's coming vertically down to the object. It is plus 10. And F4 is in the opposite direction. So it is minus 10. So plus 10 minus 10 gets cancelled, plus 10 minus 10 gets cancelled and the net force will become 0. If the net force is 0, there will be no change in the object. The object will remain, if it is in the state of rest, it will remain in the state of rest, and if the object is in motion, it will remain in the state of motion. That is what is about equilibrium. Let's see the definition. Several forces acting on a body. So see, there are so many forces acting on a body do not change either state of rest or the state of motion, then the body is said to be in equilibrium state. Yes, then the body is said to be in equilibrium state. Then what are the types of equilibrium? We have only 2 types of equilibrium of a body. Number 1 is static equilibrium and number 2 is dynamic equilibrium. Let's see static equilibrium. As the name says, static means stable. See, several forces acting on a body do not change its state of rest is called as static equilibrium. Example, a book lying on the table. A book will lie on the table only in the state of, of course it is in the state of rest. It will lie on the table only unless and until an external force is applied on it. That is what is static equilibrium. See, a book lying on the table, assume one force is applied from this direction, another force will applied on this direction, one from downwards, one from vertically from vertically it is towards the object. So all four forces acting on that object, the object or the book doesn't move from the table. That is what is static equilibrium. Next, second, dynamic equilibrium. Several forces acting on a body do not change its state of motion. Static is state of rest, dynamic is state of motion. Assume an object is moving. Let's see raindrop falling raindrop, it is in continuous motion. So it's with a uniform speed. One raindrop is not coming with a very high speed and another raindrop is not coming with little less speed. It's that all the raindrops come with a uniform speed. So it is in the state of motion only. See, several forces acting on the body do not change. Though any forces acting on the same raindrop, it doesn't change its state of motion. It will remain in the state of motion. That sort of equilibrium is called as dynamic equilibrium. Then, what are the conditions for a body to attain its equilibrium state? Number one, the resultant of all the forces should definitely be zero. What did we get here? We have seen that the net force is zero. So, the resultant of all the forces, it's not that only four forces. So many forces act on a body, whatever may be, the resultant should definitely be zero. That's the first condition for a body to attain its equilibrium state. Second one, the algebraic sum of moment of all the forces. Whenever we use the term moment, we should use at one side or one end it should be fixed. See, about the point of rotation, where is it fixed? If it is fixed on this side, the other end is the point of rotation. Likewise, algebraic sum of moment of all the forces acting on a particular body definitely should be zero. Yes, if these two conditions are satisfied, then the body is said to be in equilibrium state. Continuing with principle of moments. This is a very important definition of this chapter. Let's see principle of moments with an example. Let me take a rigid bar which is pivoted in the middle and two forces acting on either sides. Force number one acting on the rigid body one side and force number two acting on the rigid body on another side. So since it is pivoted, both are rotated clockwise direction. See, this is what. And the distance between from the force or that is on one side to its pivoted center is R1 and from force 2 to its pivoted center is R2. So this force F1 is acting perpendicular to the pivoted rigid body and its distance is R1. Force 2 pivoted perpendicular to the pivoted body and its distance, perpendicular distance is R2. Now, the algebraic sum of moment of these two forces can be written as F1 plus R1, F2 plus R2. Yes, so this algebraic sum of moment of forces will definitely be zero as already said. So thus the body will be in equilibrium state. Since both the forces acting on both sides, on either sides are equal, the sum resultant of both the forces will be zero and the body is said to be in equilibrium. So the principle of moment states that in equilibrium state, the sum of clockwise moments and anti-clockwise moments is equal to the sum of anti-clockwise moments. That is, the sum of clockwise moments is always equal to the sum of opposite side anti-clockwise moments is the principle of moments. F1 into R1 is equal to F2 into R2. That is your principle of moments. This formula F1 into R1, F2 into R2 is very important formula to be solved for most of your numericals. Yes. Next important topic is center of gravity. As the name says, it is gravity. We all of us know gravity is a force of attraction. any object, any heavy weighted object tries to pull the light weighted object towards itself. That is called as force of attraction. The very common example or the best example for this is your earth. Why is earth pulling the light weighted objects? Because it has a more weight. Then what do you mean by weight? Is this word weight equal to mass? Weight is nothing but the force by which an object is being pulled towards itself. Any object due to its heavy mass, heavy denser particles in it is being pulled by force. That is called as weight. Example I am telling, there's a particle here with a definite mass, with a certain mass is being pulled down due to gravity. So the weight is equal to mass of the substance into its gravity. That is what is your weight. Let me take a rigid body P, Q and R and S. We have 4 different points here, P, Q, R and S in this rigid body. So a weight 1 is suspended at point P, weight 2 is suspended at point Q, weight 3 is suspended at point R and weight 4 is suspended at point S. The perpendicular distance between each points, if you see, that is your P and Q is x1, Q and R is x2, R and S is x3 and from S to the end of this bar is your x4. So it has 4 perpendicular distance. Now can we replace all these forces by a single force? Let's see. Let x be the distance of forces and we have x1, x2, x3, x4 and so on. Since we have 4 forces, we are just denoting it with x1, x2, x3 and x4 only. So let's see, W1 into x1, as we have said, if forces are acting on it, we will denote it with F1 into R1 equal to F2 into R2. Only 2 forces are acted on this rigid body. I am just writing F1 into R1 is equal to F2 into R2. Since forces are acting, I am writing it as F1. Here I am suspending weight. I am suspending weight at this point. So I am replacing F1 in the formula with W1. So it is W1 into x1 or your perpendicular distance R1 plus W2 into x2 which is moving in a clockwise direction, and on the other side if you see W3 into x3 plus W4 into x4. Assume these 2 is moving in the, once take a rigid body, if you are going to rotate this here, of course the other one will move in the opposite direction. If this is coming down clockwise direction, the other one will move anti-clockwise direction. That's why I am telling you W1 into x1, W2 into x2 is clockwise moments and W3 into x3, W4 into x4 is anti-clockwise moments. Thus, according to principle of moments, the sum of clockwise moments is equal to the sum of anti-clockwise moments. Continuing with this definition of center of gravity. Center of gravity can be defined as the point at which the algebraic sum of the moments of weights of all the particles would be 0. See, the point at which the sum of all the moments of weights or the sum of moments of all the forces will be 0. It is the point where the algebraic sum of total number of forces or total number of weights acting on that single point is called as center of gravity. See, let me take an example. I have taken an irregular body. Irregular body, it's not regular on all sides. See, this I will call it as a regular body because it's even, it's the same throughout its body. But here it is not same. If you see on one side it is plain and on the other side it is being bended down, and moreover here it has less surface area and here it has more surface area. So thus I am calling it as an irregular body. So this irregular body is 100 centimeter. So I have taken a 100 centimeter irregular body. Now tell me, where is center of gravity situated for this irregular body? Where is center of gravity situated? In the right. See, in the right side or in the left side. So right side, if you see, this is been bended down, and if left side, if you see, this is been straight. So where is center of gravity situated? Here, 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 or here. The center of gravity is situated towards the place or towards the end where there is more mass. Now tell me, where is more mass? It's here, this side. If you see, the mass is more, the surface area is more, the mass is also more in the right side of the pivoted end. So the center of gravity will be towards right side of the pivoted end. That is what is mass I have written here. So where is center of gravity situated? Center of gravity will always be situated where there is more mass, nearer to the pivoted end. Okay, so center of gravity is situated towards the point where more mass is present. Next question. Can center of gravity be situated outside the material? Outside the material doesn't mean in English terms, that is a material is there and it outside. It's not that. Outside the material means, is it present inside exactly in the corner, in the center, or in the sides? They mean to say in the sides. So that is what their question. Can center of gravity be situated outside the material? For that, I have taken an example of a ring. Assume this is the ring, and how to find center of gravity for this ring? This ring, I can call it of two ways. This ring has halo in between, or this ring is completely filled in between. First, initially I have taken a halo ring where it has a space in between. Now where is center of gravity situated in such case? In this case of irregular body, I said the center of gravity is situated near the mass. Where there is more mass, center of gravity is situated to that end. Now here the mass is evenly distributed, isn't it, throughout this hollow space. Where there is mass here, the mass is very less throughout. Now in such case, the center of gravity is situated throughout the diameter of the ring. So throughout the diameter of the ring, that is exactly here, at the center is your center of gravity. In the halo case or halo ring or halo material, the center of gravity is situated along the diameter of the material. Diameter of the material means not throughout the material. It's exactly at the center of the material. Next, where there is no mass, center of gravity is situated outside the material. Now I have asked the question, can center of gravity be situated outside the material? Yes, it can be situated, but the particular material shouldn't have any mass. If the material is not having any mass, the center of gravity will be situated outside the material in such case. So this center of gravity depends on two factors. Number one, shape of an object. Number two, mass distribution in an object. What is shape of an object? How does the center of gravity depends on shape of an object? Let me see. I have taken a bar, a rigid bar, okay, where it has center of gravity exactly here. Now I am folding the bar. I am going to fold the bar, bend the bar. See, this the same bar, I have bended it to this shape. I have bended and folded it. In the sense, I have bent to a circular shape. Now tell me, where is center of gravity? For this object, where is center of gravity? Actually, if you see this center of gravity, when I am bending this exactly, this point, the COG point has to be here, according to this diagram. But the center of gravity is situated exactly at the center, because we told that for a hollow ring the center of gravity is situated exactly at its diameter. So when it has been bent, it forms a halo sphere. It has a halo in between. So the center of gravity is situated along the diameter, that is exactly at its center, not at this point. That is what is center of gravity depends even on shape of an object. The second factor is mass distribution. For example, I have taken two cones, a hollow cone and a solid cone. A hollow cone, as already said, it will be hollow in between. Here solid cone, it has mass throughout this cone. The mass is distributed throughout this cone, whereas here the mass is not distributed, it's just a hollow. So in such case, where is center of gravity? If the mass is situated here, here will be the center of gravity for it. Exactly here. And if the mass is not situated like this, it will be at the diameter of the ring or whatever it is. I said here, if it is like this, center of gravity, hollow material, then the center of gravity would be located at its diameter. So this is hollow cone and center of gravity is located exactly at the point of its diameter. And same way here, where there is more mass distribution, the center of gravity will be located. We cannot say it is exactly at its center. That is what is the factors for center of gravity. The last topic of this center of gravity is center of gravity of some uniform objects. Let me take an example. I have taken a square object. Its geometry is like this. Two diagonals are meeting at a point. So where is center of gravity? The center of gravity will be at the intersection of those two diagonals. That is exactly here is the center of gravity. Next, I have taken an rectangular object. See, this is your rectangular object. It also has diagonals. Where is center of gravity in such case? In such case, center of gravity is also located at the intersection of diagonals. That is exactly the diagonals meet at here. So this is what is center of gravity. The third example is I have taken a triangular body or triangular object. See, look at this triangle. So it has an intersection like this on all three sides. So where is center of gravity? Intersection of those medians. See, if you see this intersected at this point, all three are intersecting at this point, which is called as a median. So this median is the center of gravity for triangular object. Next, cylindrical object. See, assume this is your cylinder and it runs an axis like this and one more axis vertically. So it has an horizontal axis and one vertical axis. So where is center of gravity here? Midpoint of the two axes. So this is x-axis, this is y-axis. Center of gravity is located exactly at the midpoint of two axes. So this is your center of gravity of regular uniform objects. Thus, we end up this center of gravity and your introduction for force and moment of force with this video. In my next video, I will be solving numericals for you. Each and every numericals I will be solving with formulas. If you like my videos, please click like button, share it with your friends and don't forget to subscribe my channel. The support is my strength. Thank you.